Hey guys, welcome back. So for today, we are going to see in the last 2 days what we have covered. We are going to have a theoretical walkthrough around loops and functions. So I have drafted this PowerPoint presentation with whatever we have discussed so that you get a quick reference around it. And also towards the end of this video, we are going to talk about a few questions that might be possible or some questions that might come up in interviews, right? And that would help you to get a hold of whatever we have gone through until now, right? So we have seen loops in Python. What are loops? A block of code that is repeated multiple number of times based on certain conditions, or it may be just using a range in for loop. We have seen that, right? So we have seen for loop and while loop in Python. So a basic for loop has for I in a range, and we can also customize the range to whatever iterations we want. We have in the second one, if you see, we have for I in range starting is 2, the upper limit is 10. So ideally this is the upper limit, but in actual it would be upper limit minus 1, right? And in here we are incrementing it with 2 each time, right? So the output here would be 2468, right? So 10 is skipped because the loop would start from 0 to 9. That's how it works. And then we had seen looping in a string for x in banana. So this would print all the alphabets separately. B, A, N, A, N, A will be separate alphabets that we'll get out of this loop, right? We had seen while loop. While loop is basically a condition based loop where we give a certain condition along with while. So we have given while when count is less than 5, we are printing the count and we are incrementing the count variable with 1. Okay. Then we have infinite loops. To terminate infinite loops, we have break statement, and then while can be followed with multiple conditions as well using and or keywords. You can also club it with multiple while loops inside a while. You can also have for loops inside it also. Now loop controls, we have seen break and continue. Break is to break the loop. The entire execution of the loop would be completed whenever it encounters a break keyword, and it would just continue with the next line of code. It would come out of the loop statement. Whereas continue would just skip the current iteration and it would again go back to the loop heading and it will start reading your loop again, right? So continue just skips one iteration, whereas break would just come out of the loop, right? And then we have nested loops. You can use multiple for loops. So these would be advantages when you have web tables. You have to go through each rows and columns. You can use multiple for loops to just traverse your rows and columns there. Okay. Then loop with else clause. Else is nothing but it just prints a certain line towards the end of the loop saying the loop was executed successfully without any breaks encountered, right? If there was any break encountered in this particular for loop, this else statement will not be printed. Now functions in Python. Now functions are always defined with the keyword def when we are defining, and while calling we just have to call the function name, and if there are any arguments we have to pass it there, right? So if you see def greet and a particular argument is passed here name, so it is printing name. Now there are positional and keyword arguments. Positional is seen by the position of the particular variable that we are passing. So say 5 and 10 gets placed as A and B here. Whereas in the second one, we have keyword where B is passed first and A is passed in the second one, right? So this is called based on the actual variable names rather than the positional. So there are two concepts, positional and keywords. Clear? Now default parameters are again nothing but if there are no arguments passed, then a particular default argument or default parameter is accessed. Say while I am calling this greet function and I'm not passing any, I'll just say greet. I'll just call the function greet. So by default, it will print hello guest. If I pass argument here, say I'll say greet and I'll say in my parameters, I'll pass John. So it would again print hello John, right? Return statements are the values that are returned from a particular function. So if you see this example, I'm returning number into number, right? So what it will do, it will give me a square of it. So whatever values I'm passing, I'll be getting square of it, and I need a variable to store the returned value, so which is stored in this variable result. Now, local and global scope of variable. Local is something that is very much defined within the function. Global is something which is defined outside of the function, and it is accessible to all of the other lines of code. Whereas this local variable is only accessible when this function is being called, right? If you want to print this message outside the function, then you'll get a name error saying the scope of variable is not defined, right? Then we had two other things. We had args and keyword arguments. So args and kwargs. Okay. So they are also known as flexible function signatures. When you are not sure of the arguments, whatever arguments you are receiving in a function, you can use these particular keywords. So if you just give args, it takes n number of inputs in your input parameters, in the function input parameters, and then you can perform your actions on it, right? Whereas keyword args also takes n number of inputs, but it will take in a key value pattern, right? So they are also keyword arguments and prints, and this would store it in a key value pair. And last one we saw was lambda functions. Lambda functions are nothing but throwaway functions. You can use it just once, right? So here we are just trying to square a number again by using a lambda functions. Yeah, we have seen this already, right? This is just for your reference. Now, the next thing that we want to see here is the interview preparation questions. Okay. So this one I have already have. I have already. Let's exit this. I already have it in my PyCharm that I have here. Now let's take each of these example individually. So let's go here. I'll answer it here itself, right? The first one. What is a for loop in Python and how does it differ from a while loop? So let's write the structure first. How does a for loop works? For I in range of 5, right? I'll say print I. Okay. And if I want a while loop, how it is, I'll say count is equals to 0 while count is less than 5, print count, and I'll increment the count. Okay. Now both of these functions are doing the same thing. Now if you closely observe, loop is just iterating. Loop is just iterating over a value until a certain range is satisfied, right? It it goes in a sequential way. It goes until your upper limit, and once all of the elements in the sequence is processed, it exists, right? Whereas while is more conditional based. Yeah. So the condition is checked before each iteration, right? If it is false, then it will come out of the loop. And if at all this particular condition is false in the first place itself, it won't even execute it. Okay. Whereas while also needs an explicit condition to stop. So for is sequential execution, whereas while is conditional based execution. So when do you use while and when do you use for, right? So for is used when you know that you are going to repeat a certain action in certain set number of times, right? Suppose you are iterating through a particular table and you know there are 10 columns. I need to iterate through the 10 columns. So I will use a for loop there. Whereas while loop is used when you are aware that there is certain conditions that I need to check. Say you have a dynamic table and you whenever you keep scrolling, the list comes up, right? Whenever you reach the end of the page, there is another table that is populated or another set of values that is populated, right? So in that condition, you need to have a conditional based approach rather than a fixed number of iteration, right? So that's where while will come into picture. All right. So the next one, how do you use range functions in loop? So we just saw this, right? When so there are two ways of using it, right? Let's give an example here. So you can have it like this. You can also have it like range 1 to 5. Now, how this is different? If you execute this range, you will get an output of 0, 1, 2, 3, 4. All right. Whereas when you define your starting index as 1, you get the output as 1, 2, 3, and 4. Okay. Both of these way you can use range. Both are correct. Okay. What is else block used for in Python loop? And there is one more way. I skipped this. There is one more way, right? We had seen this range. We can specify it like this, right? Then what happens? It would print 1, 3. That's it. Would print 1 and 3. Okay, moving on to the next one. What is the else block used for in Python loop? We had seen this example, right? We just gave an else statement. Just outside my Python loop. Let's take this example, right? So the else block in Python loop is executed only if the loop terminates without encountering a break statement, right? This is used when we have a loop which is totally completed its execution and there was no early terminations in it, right? So that's when we will see this particular print message on our screen, all right? What is the next one? How can you terminate loop early in Python? So how do we do it? So to terminate the loop, we have a keyword break, right? We use the keyword break to terminate the loop. What we are doing here, we are running a loop from 0 to 9, and if I is 5, I'll break the loop. All right. So it will print 0, 1, 2, 3, 4, and it will come out of the loop. And the next one is, how do you skip the iterations in loop? We use continue keyword here. Okay. So instead of this, the same example we can use, we'll just replace break with continue. What happens when it is 5? It will skip the iteration. So what it will print? It will print 0, 1, 2, 3, 4, 6, skipping 5, 6, 7, 8, 9. Now write a Python program to print a Fibonacci sequence using a loop. What is Fibonacci series? Fibonacci series is nothing but a sequence which is sum of its previous two numbers. So it starts with 0 and 1, right? I'll just take an example. It starts with 0 and 1. Now the next element will be the sum of previous two elements. So next element is again 1. What is the next element? Sum of previous two, that is 2. Next element 3, right? What is the next element? Sum of 2 and 3, 5. Next element 8. Next element 13. How do we do it? Using the programs, the Python programs. How do we do it? Okay, let's say we have n equals to 10, and we'll have to define our first two numbers, a and b is equals to 0 and 1. Okay, we'll say for underscore in range n. What I'll do, I'll just print here, and I'll print. What do I want to print? I want to print. Let's execute this first. I'm going to comment everything. I'm commenting my code, and I'm going to print a comma and is equals to just so that it doesn't have a line break, right? And before this, I'll print AB, right? Let's execute this. Or I don't need this print here. I don't need it here. Instead, I can just have it like this. Now let's see what happens. So it's printing the same sequence, right? 0, 1, 1, 2, 3, 5, 8, 13, and so on until the last. I gave n as 10. So how many it printed? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Because it is 0 to 9, right? I gave n as 10 and range as n. So I gave from 0 to 9. And what is this underscore? This is also a loop construct. This is used when we are not going to use this variable inside my loop anywhere, right? So I'm not going to use, even if I write it for I in range, this one doesn't make any sense. I'm just iterating, but I'm not going to use I anywhere inside my loop. So I'll just pass an underscore here. So for a variable in range this, I'm printing a first. So what is my a? A was 0, right? Then what did I do? I assigned the value of b, right? The value of b to a, and my value of b became a plus b. Okay. So what did I do? I just swapped it. So first my a was 0 and 1. After this, my value of a will become, what will my value of a become? It will become as, the output will be 1 comma 1, right? In the next iteration, when it comes here, what will the value be? It will again become, this will become as, this will become as 1 comma 2, right? And so on so forth. It will start continue, it will start on incrementing the value. I'm only printing the value of a here, right? I don't want the second value to be printed because a is only taking care of the first values that I have. So I have 0. Now next time a becomes 1, next time again it becomes 1. So it will continue until your 10 numbers and it will stop. Now you can also modify it in a way saying, I want these particular sequence to be printed until a certain number. So say if this was using a loop, right? So if this was say until 100, right? So if it says until 100, so I'm not going to use the same approach. I will change it to what? I'll change it to while loop, because that is a conditional based approach, right? So I'll use a while loop and I'll change this values to run this particular loop until my last, the value of a is just below 100. If it is exceeding 100, I want to exit that loop. So I'm giving you this as an exercise. Practice this, come up with some solutions. I have given you the solution, but come up with some approach how you can tackle it, right? So don't use for, or you can try using for as well. You can do it using for as well. There's no hard and fast rule that you have to use while, but I'll suggest use a while loop here. Okay. All right, let's comment this. Moving on to our next question. What is an infinite loop? How do you avoid it? How do you avoid it? So, what is an infinite loop? An infinite loop is a loop that keeps running indefinitely, right? Uninterrupted and indefinitely, because there is no exit condition to it, right? How do you stop it? How do you stop it? You are going to use what? You're going to use a break statement, or you are going to use a pattern or a condition based approach where you don't end up in a situation where your loop is running infinitely, right? So this usually happens when you are doing it with while. So you are expecting certain conditions, but the condition is not met, right? So you have to define your loop in such a way. Say I want to go for 100 iteration. If it is not found in 100 iteration, I want to come out of that loop. I don't want to keep on waiting forever. So you have to smartly program your loop in such a way that you don't end up in a situation where you are running an infinite loop. And if the loop is running for infinite number of times, you have to have a break statement, right? So you have There are two ways you can do it. You can either do it using break statement, or you can either do it using conditional loop, so that it continues. You don't have to, so it breaks the loop. It doesn't continues forever, right? There are two ways. Can you nest loop in Python? Yes, we can. We have done this already. We had seen this example, right? I had that in my PPT as well. So I'll just use the same example here. If you guys want to play around this, you can try to tweak this code and use it in a way however you want. You can use two while loops as well, or you can use one for loop, the second one as a while loop, right? Okay. So this is how you are nesting two for loops, right? What is the difference between continue and pass in loop? So we had seen continue. Continue just breaks one iteration. Pass is used when you don't want any line of code inside your functions, right? Right. So continue statement skips the current iteration of the loop, whereas pass will just say it does nothing, right? Let's take an example here. I have this. So what I'm doing here is, when I'm running a loop from 0 to 4, if it is 3, I'm saying just continue. So skip the current iteration when it is 3 and you print everything else. Whereas what I'm doing here is, if it was 3, I'm saying pass, which is doing nothing. So it will again print 1, 2, 3, 4. I mean, so 0, 1, 2, 3, 4, right? Because it is 0 to 4. Okay. Write a Python program to check whether a number is prime using a loop. Okay. How do you do it? What are the things that we are going to check for a prime number? A prime number is number 1. A prime number is divisible by 1 or itself, right? So we have to check if a number is divisible by any other number apart from 1 and itself, then it is a prime number. I mean, it's not a prime number. So if it is only a prime number if it is divisible by 1 or itself. Now, so what do I want to do? I will want to run a loop. I'm not going to write this program. I'm leaving it to you. I'll give you a different example solution here. But what I want to do here is, what I want you guys to do here is, you run a loop from 2 until n, run a loop from 2 until n, or whatever input variable you have, and check if it is divisible by any number in the loop, right? So you can also run it using n until n by 2. Sorry, n by 2. Use n by 2, because if you are running for a loop, if you are checking for a number, say 10, it can only be divisible by 5. It cannot be divisible by 6, right? So if you are looking for 10, and I know 10 is not a prime number, so the biggest factor for its division is 2 and 5. There are two numbers. If you are going to multiply this, it's going to be 5, right? Correct. So use a loop until n by 2. So whatever it is, 10 by 2. So if it is even number, it is anyways not going to be divisible, right? I mean, it's not going to be a prime number. If it is an even number, it's not going to be a prime number. To check that, you'll have to divide that number by 2 and see whatever you run a loop from 2 until n by 2 and see, and you need to convert it to an integer, right? Convert this to an integer and run a loop and check if it is divisible by this particular I, or whatever variable you are taking in that loop. If it is divisible by I, you are going to use that particular condition uh, saying if it is divisible, then it's not a prime number. If it is divisible by any of it, it is not a prime number. But if it is not divisible by any of those, it's a prime number, right? Now, that is one approach. That is one approach. Now, to optimize it more, what we are going to do is I'm going to use same thing. I'll say a number that I want to check is, where am I writing? Okay, number that I'm going to check is number is equals to, let's say 29. 29 is a prime number, right? 29 is a prime number, and I'll have a condition checker is prime is equals to, I'll say true. I'll say for I in range, I'll use 2 comma integer of number square root of it plus 1, right? And I'll say if number mod I is equals to 0, I'll say is prime as false, and I'll break it. This is my for loop, and towards the end I'll check if is prime, right? Then I'll say print the number, or else print the number. Now let's format this. This was auto generated, so I'll have to format this. The number is prime. Similarly here, I need a colon here. Else format this. The number is not prime, right? I'll have the same thing here. The number. Now let's try to run this. One. And from where do I want to uncomment? From here. Now it says 29 is prime. Now what did I do here? If you want to understand this, let's take an example here. Let's take an example. If number was let's say 16. So we only need to check the number up to the square root of n, or up to the square root of number, right? Because if the square root is divisible by the larger number than its square root, then the corresponding smaller divisor would have been already found, right? So let's take an example, right? Let's take an example. If it was 36, right? So divisors, what are its divisors? Divisors would be 1, 2, 3, 4, 6, 7, no 7, then 8, it's what? No, it's 16, right? No, it's not. Bigger number, 36. Now the divisor would be 1, 2, 3, 4, 6, and 7, no, 8, 36, no, 9, yes, 9, then 12, then 18. So 18 is just half of 36. So anything after this is not counted, and then it would be 36 again, right? So what I'm trying to do here is I'm trying to do a square root of 36, right? So I'm trying to run a loop from 2 until square root of 36 plus 1, right? So what happens? What is the square root of 36? So square root of 36, square root of 36 is 6, right? So square root of 36 is 6, and 6 is already, if you see this divisors, so you already have a number which are fitted, right? The corresponding divisors are here present already, like 2, 3, 4. So 36 is divisible by these numbers. So I only want to check until the square root, and once I have this number, or if it is divisible by any of these, it's not a prime number. If it is not divisible by any of these, it's a prime number. Similarly, in the case of 29, So what I'm expecting? I'm expecting, so if you do a square root of 29 is equals to how much? Let's calculate again. So square root of 29 is 5.38. Let's take this, right? So, and what I'm doing, I'm converting this to an integer and I'm incrementing it by 1. So let's say it's 6 now, right? So it is 6 now. Now, if I want to calculate the divisors of 29, what I want to do, I want to start from 2. Like in my loop, I'm starting from 2 and I'm going until 6, right? To check whether any of these can divide 29. So if I go with 3 not divisible, 4 not divisible, 5 not divisible, 6 also not divisible, right? So this is optimized and efficient way how you can check a prime number. So if you run this, it was 29, it showed it's a prime number. Let's run it for some other numbers as well. Let's say 7, and 7 is a prime number. Now let's say 12. So 12 is not a prime number. If you want to see what numbers I am passing or how it is handled here, so you can print these numbers. You can print number comma I. So so you can see what is being calculated. I mean, what is the number that is generated here and until how many iterations it is running. So anyways, it first ran with 2 and it found that it is divisible by 2. So it broke the loop. It came out saying it is not a prime number. I am able to divide it by 2. Now let's run it again for 29. Let's run it again for 29. See. Okay. So first time it checked with 2, 3, 4, 5. And we were supposed to go until 6. But my loop upper count is 6. So it will run only until 5. Because it should check the numbers with until the square root values, right? I wanted to check until 5. So I wrote +1 here, right? So I deleted 6. But the checking would happen only from 2 to 5. Correct? Okay. Now let's comment this. None comment. Everything else. Let's take the next example. How do you define a function in Python? How do you define using the def keyword, right? Using the def keyword, we have to define a function. We'll define it using the def keyword. Let's say greet John. Okay, this is simple. What is the difference between return and print in a function? What is the difference? Let's go here. I'm using the same example. I'm just going to use the same statement, and instead of return I'll say print. Now what is the difference here? So return is used to send this particular value back to the calling function wherever it is being called from, right? So this particular value is returned to this greet method here, and it would again need a variable. So let's take variable is equals to, and whatever is being returned from here is stored in this var, right? And this happens towards the end of the function. You cannot have it in somewhere in mid of the function. You can have it, but as and when this statement is encountered, that marks the end of this function. Whereas print will just display the value in your output section, right? It is not being stored anywhere. It is just being displayed here in your console. It is solely for displaying the information, or solely displaying the values what is being passed here in this example, right? It is not stored anywhere. It is not being assigned to any variable. It is just putting a message in your console. Whereas return returns the variable to this particular calling function, and this explicitly stores it in a variable here. Now if you want, you can print this variable also to get this on your console, or else you can use this however you want to, right? Can a function return multiple values? Provide an example. Yes, it can return. We had also seen this earlier, how to return multiple values. Let's take the same example here. We'll try to modify it. How do we do it? So it takes name here. I'll suggest greet. Let's remove the calling instance as well. So if you want to return multiple values, how do you do it? You can just use comma separated parameters. So I'll say 1, comma 2, comma 3. So it is returning 3 values. Now to store it, how do you store? A, comma B, comma C is equals to greet. So it will return 1, 2, 3, and those corresponding values will be stored in ABC. Clear? What is recursion? Write a recursive function to calculate factorial of a number. Right? What is recursion? Recursion is nothing but a function calling itself. Okay. And what is factorial? Factorial is a number being multiplied from 1 until the number itself. Right? So what is recursion? A recursion is again a programming technique where a function calls itself, and each recursive call reduces the problem size until it reaches its base case, right? So let's see how that works, right? So we are trying to do a factorial using a recursion, right? So what is factorial? What is factorial? So if you want to do a factorial of 5, right? So how will you do it? So 5 factorial would be 5 into 4 into 3 into 2 into 1, right? So this is 5 factorial. And how do you denote it? Let's say 5 was n equals to 5. What I want to do, a factorial is denoted by using an exclamation word, right? So n factorial is equals to this. N factorial is this. Now, how do you handle this programmatically? Okay, define factorial of n, right? If n is equals to 1, right? So if I cannot further divide it, or I cannot further multiply it, so I'll return it. If it is not, then I'll return what? I'll return n into factorial of n minus 1. So whenever it comes here, it will again call itself with the value of n minus 1, right? And same thing is being returned to the base calling function. All right. Now to check the output, what do I write? I'll say print factorial of 5. All right. So let's comment this. If we want to run this, comment this and run. What it should print? 5 factorial is 5 into 4, that is 20. 20 into 3, 60. 60 into 2, 120. Into 1, 120, right? So it should give me 120. What it is printing? It is printing 120. Or if you want to check how this is working, you can use a debugging. You can click here, create a debugging point, and you can go inside debug mode. This is the debug mode here. You can go inside the debug mode and add this value, add n, add this factorial value as well. Here, right? Here, you can just add it here, add to watches, right? And just use F8. Where is that? F8. Step over, yes. So it will come here, it will increment the value, and it will again show you how this is being proceeded, right? How it is incrementing. You can go step by step here, and just to understand your code more. What are default arguments in Python? Provide an example. What are default arguments? Default arguments are those which are being called whenever there is no arguments passed from the calling instance, right? This we had seen earlier. So default argument is guest here. If a name is passed, it will print the name. If no name is passed, it will print hello guest. All right. Can you modify a list while iterating over it? What issues can arise? How would you solve them? So modifying a list while iterating over it can cause issues like skipping elements because the list is being modified during the iterations, right? So the best way to come around this is to create a copy of the list, right? And create a copy of that list, do your accessing, whereas the original list is still being modified, right? So we'll take this up once we are discussing list objects, right? So, but I'll just write it here like make a copy and access it. Make a copy and access it. What are the variable length arguments, args and kw args in Python? Provide examples. What are those? We have seen all these, right? Simple. I'm just going to use the same examples that we had there. So there is a function with args, so it can take any number of arguments here. There is a function with kw args, it can take any number of arguments here, but in a key value pair. Okay, right? Can functions be nested in Python? How do closure work in Python? Provide examples. So what exactly is closure? Can functions be nested in Python? Yes, it can be. How do closure work in Python? What are closures? So closure is a function that remembers the environment in which it was created. So so this is practically possible where we have nested functions. So say function 1. So, or let me put an example here. So let's take this example. So there is an outer function, there is an inner function here, right? Closure function is equals to outer function, and I'll call it with 10. Okay, and I'll print whatever I'm getting from. Oh, sorry. I'll print my closure function with another value. I'll say 5. Let's say 5. Okay. So how this is working? So for the first time when I called my outer function, it was 10. So 10 got assigned to x. Now I'm again calling this closure function, which is stored as outer function of 10. So it remembers that outer function is called with 10. Now if I'm calling this closure function with the value of 5, what it is saying, it says I already have a value. The next function call is for the inner function, and it assigns 5 to y, and ultimately it will return me x and y, right? So let's run this one. But this example, I mean, this concept might not be very useful when you are doing with Selenium. This is for someone who is very much into Python development. This might not be a very common question, right? So we have x plus y, right, which is coming from this closure function. And again, if you want to understand how this is working, do a debug, run through it, and let me know if you have any more questions around it. Okay, let's uncomment everything else. Let's take the next one. What are decorators in Python? How do you use them to modify the behavior of a function? This is a good question. You're going to use this. You're going to use this a lot, especially when writing custom functions in Python, right? So what are decorators? So decorators are some functions that can modify the behavior of other functions, right? So in normal terms, while we are scripting, we'll use it to add functionalities like logging or caching without modifying the original functions code, right? So it is how do you implement it? Implemented using @symbol. Okay, let's create a function. Let's say def my decorator takes an input as a function and define wrappers and take anything, or let's not have anything actually. So it's an empty function, right? We'll say print, let's say before function, and we'll have the actual function execution. We'll write print after function. Okay, and what we'll do, we'll return wrapper. Okay, so what this is doing is we have this function, my decorator, which is taking function as an input, and what is happening, we are writing a statement before the function execution, a statement after the function execution, and we are returning the function execution value, whatever is being executed, right? So how do we implement it? Let's say we have a function called definition greet, and I don't want anything here. I have a definition greet, and it says print hello world. Okay, now while calling, how do I call it? I'll just say, for now, I have defined my decorator, or I have defined uh, the behavior of the decorator, but I haven't used it, right? So let's run this first. What will I get? I'm just getting hello world, right? Now, but before this particular function, I am going to give this particular my decorator that I had just defined, and let's see what it returns. So it returns before function, and then hello world, and then after function. As in, when you are creating your framework, you'll find these very helpful, and we'll use more when we are doing a framework level designing. I'll explain how this works or where this is useful. Okay. Uh, uh, Write a function to calculate the nth Fibonacci number using memoization, decorator, or dictionary based. Okay. I think this is too complicated for now. I'll take this once we are doing our dictionary and other object types. When we're done, I'll pass it on. I will pass on this question to the other session after we have completed the dictionary concept, right? I'll show you both the approach. Explain how function annotations work in Python. It's kind of a metadata attached to the function, right? So it's kind of a metadata that what the function parameters are and what's the return values that we are expecting, right? They do not it doesn't have to do anything with the function's behavior. It's just kind of a metadata or kind of an information attached to that function. So how do we do it? So let's say we have a function define add number. We'll take int int I comma int, sorry, x is equals to, I mean, x is expected as int, whereas y is expected as int, and return x plus y, right? So print add numbers set to, so it says x is supposed to be an integer here, right? Let's take this also. I have another add numbers, add number, let's say add numbers. Okay, and I'm not going to provide this. Now if I want to print add numbers, I'll say, so it just says you need to input x and y, okay, and of type what, I don't know, right? So I'm just saying 2 comma 3, whereas when I'm trying to assign value to this particular function add numbers, what I'm getting, as soon as I write 2 or say any number, I'm sorry, okay, as soon as I write 2, so in the hint it says x was integer and y should also be an integer. That's kind of an hint that is giving me. So I'm expecting x as integer, y as integer, and my return should be of type integer, right? Whereas if you see in the first one, I haven't defined the type of variable that I'm expecting. It can be a string, it can be a function. I mean, it can be an integer, float, or a string. But here I am trying to hint it that okay, this I am expecting an integer here, I am expecting an integer here, and my output will also be an integer. That's the kind of hint that I am passing, right? So this is how annotation works in Python. Okay, so that was all that we wanted to cover in this lecture. We'll see you in the next one.